we go. All right, so today is September 1st. And it's section P-7. So like I said, we're still reviewing. This is going to be a brief review of solving equations. There may be some that we do at the end of that you didn't do a lot of in Algebra 2. Okay, so you might actually see something that's new today. All right, there are some special cases or special types of answers. So let's call these special cases. We know that when you've got some type of an equation, most of the time when you go to solve it, you get x equals 4 or x equals -3 or whatever. You do not always get that. So if I had something like 2 times an x plus a 3 equals a 2x plus an 8. All right, now when you just randomly look at this, you're not going to necessarily know anything. I mean, people that can do a little bit in their head and think forward about what's going to happen can see it, but if not, it's perfectly okay if you don't recognize this as being anything special, because you might just go ahead and start. You're going to what? Distribute that 2. You'll have like a 2x plus a 6 equals a 2x plus an 8. All right, even at that point, if you're not really thinking about what you're doing and you're just cranking out algebra steps that you have done for so many years, you still may not, at this point, you may not catch it. All right, but obviously what? We move the letters to the left, we move the numbers to the right. So if I did a -2x and a -2x, all right, well, 2x minus 2x falls out, right? That becomes 0. 2x minus 2x over here falls out. That leaves me with a 6 equals 8. All right, which we obviously know that's not a true statement. That is false. Okay, so what type of answer do I write down? Anybody remember? Carly, what'd you say? No solution. All right, because that's a false statement. I cannot find an answer from my variable to go in there. All right, and in the past, you might have done an entire section where all of your answers were no solution, or the other one that we're getting ready to do. All right, but now this is just going to be mixed in. So you're going to work your problems out. You're going to get several answers, but then you could get a no solution, or you could get the second type. Okay, let's suppose you had, and again, I'm not going to necessarily write down the whole thing. Let's say you've got an equation, you work it out, you work it out, you work it out. And when you get down here at the bottom, let's say you get 12 equal to 12. All right, well, that's different than this one. This is true statement, 12 equals 12. So what's the answer for this? Well, it will be infinitely many solutions, but I don't want you to write infinitely many solutions. What that means is, yes, I can take any number and plug it in for x and make the equation true, but I want you to call this an identity. Okay, so don't make that mistake. Yes, it is true that there are infinitely many solutions, but what that means is that really turns out to be an identity type of an equation. All right, so are we good with those two cases? All right, now you're going to also see equations that have absolute value bars. All right, as a suggestion here, always isolate, I'm just going to use the word isolate, best way to describe it, always isolate the absolute value bars. All right, because there's a trick to solving absolute value equations. You want to isolate them first. Okay, so if we go back and think about just absolute value in the most general sense, if I said absolute value of x equals 8, and I ask you to solve for x, well, how many different choices could I put in for x to get that to equal that? I could plug in 8, right? Could I also plug in -8? Okay, there is the base idea for this. All right, x could be the 8, or x could be a -8. So when you're dealing with its absolute value, there's two possible answers. And breaking this up into two different equations are going to get you that. Now, obviously, this one is a think thing. You're just going to think about that one. All right, but notice there is nothing being multiplied by that absolute value bars, and there's nothing being added or subtracted out here. It is isolated. It's by itself. Okay, so now what you're going to see is maybe something like 2 absolute value 3x minus 4 plus 6 equals 18. All right. So when I use the word isolate, the absolute value bars are not isolated because there's a +6 and there's a -2. So you got to get rid of all that stuff first. All right. So subtract your 6, get rid of it. All right. So then we're going to have what? 2 absolute value 3x minus 4, and then 18 minus 6, 12. All right. Keep going because it's still not isolated. So divide both sides by 2. All right, now finally I get down to an absolute value of a 3x minus 4 is equal to a 6. My absolute value bars are now isolated. So now, just like we did here, I can break it up. The first equation I always write, I just drop the absolute value bars and write it the exact same thing again. So 3x minus 4 equals a 6. All right, or over here, do it again, but then you take the opposite of what's on the right-hand side, basically. So 3x minus 4 equals a -6. And then hopefully these are two nice, easy little equations that you can solve. I'm not going to show all the work here. On this one, you're going to get down to x equals 10/3. Leave it like 10/3. No reason to go to a decimal. No reason to go to a mixed number. All right, do this one over here. I think this one turns out to be x equals -2/3. All right, since this is a review section on equations, you can do two-step equations, not a problem. Now, 2 answers. You should use a solution set for your answers. So, set brackets, all right, -2/3 and 10/3. All right, so let's call this a solution set. If you have more than one answer, put your answers in a solution set. All right, and probably in algebra 2, they just let you write x equals 10/3 or x equals -2/3. All right, but now let's step it up one more time, use some set notation, and write them as a set because you got to answer sets. Okay, are we good there? All right. Next type of equation that they're going to expect you to already know how to do, all right, is quadratic equations. Okay, so quadratic equations are what? They have an x raised to the second power, right? So basically these are your x squareds. Okay, so there's different ways you can do this. What's the easiest way to solve a quadratic equation? Do we remember? What's the easiest way? If I don't want to actually do one yet, but if I had something like x squared minus 3x minus 10 equals 0. What'd you do? What'd you do last year? Oh, say it louder. I don't want to add 10 to 0. I don't want to add 10 to 0. Someone said factor. Did I hear someone say factor? Yeah, remember we would factor this and then set this one equal to 0 and set this one equal to 0. All right, so factoring is an option. And if it factors, that's one of the easiest ways to do it. All right, obviously, if it's a quadratic equation, then we could use quadratic formula, right? So that's a possibility. And technically, you could even use the quadratic formula on one that factors if you wanted to. I wouldn't recommend that because it's going to take you longer, but you could do that. All right, and then honestly, I don't know, you should have been shown how to complete the square. All right, that one is the least favorite. People usually don't use that one just because it's a little bit more challenging. All right, as long as you can definitely do the quadratic formula, you can solve every one of them because quadratic formula works for everyone. And if you know how to factor and can factor, that's easier to do than that. Technically, you do not have to learn how to complete the square, all right, because quadratic formula works for every one of them. Okay, so I will not force you to do this, all right? I will not force you to do it. So let's actually let's just go ahead and do that one since I wrote it up there in the corner. Let's go ahead and go x squared minus 3x minus 10 equals 0. All right, everything's on the left-hand side. It's set equal to 0, so we are good. All right, this one looks like it does factor, so we clearly want to do factoring if we can. All right, it's a leading coefficient of 1, so that first term is just going to be x and x. My only choices for that 10 are what? 10 and 1, that's not going to work. 5 and 2, that's going to get me a 3 in there. So I'll put a 5 in one of the spots. I'll put a 2 in the other spot. They've got to be unlike signs because I need a negative 10. It's got to be a negative 3. So that means the 5 is the one that's got to be negative. All right, set them both equal to 0. And most of the time, I don't show that step. X plus 2 equals 0. I don't show that step. You're more than welcome to show it. I just go x equals negative 2 because it's a one-step equation. Here again, I probably would not show that equals 0 step. I would just write down x equals 5. All right, but we have two answers, right? So we do solution set, negative 2, 5. Okay, put that answer in that solution set. All right, now, do we have quadratic formula memorized? Let's get rid of that right now, in case you don't. All right, so now we have a tendency to just write down negative b plus or minus the square root of b squared minus 4ac all over 2a. We have a tendency to do that. Technically, this formula should start with x equals, and then that formula, because when we solve an equation, what do we get done? We get done with x equals, right? So that should be part of it. And then it goes along with those a's, b's, and c's. At this point, we know this, I believe. We know that, where can I write it really good? It's an ax squared plus a bx plus a c equals 0. All right, so the a's and b's and c's are your coefficients in here, and then your constant right here is for your c. All right, so just as an example, because it's probably been a while since you've done a quadratic formula. All right, let's suppose we've got an x squared plus a 5x plus a 3. All right, checking. This will not factor because 3 times 1, there's no way I can get a 5 in the middle, so it does not factor. Okay, so go through. There's an imaginary one that sits right there, so that's my a variable. The 5 is the b variable, and then this is your c variable. So you go through the equation, you pick your a, b, and c, and then it's a matter of plugging it in. And technically, you really should start with x equals, but we might let that slide. So negative 5 plus or minus square root of. All right, I'm going to do a little bit of math in my head. 5 squared would be 25. I generally don't try to do this minus 4ac in my head because with negatives, you're more likely to drop a negative or whatever. So minus 4 times the a times the c. And then all over 2 times a, which is just going to be a 2. All right, this one wasn't too bad. It's 12. 25 minus 12. 25 minus 12 is what, 13? Okay, so x is going to be equal to negative 5 plus or minus square root of 13 all over 2. All right, I think for our answers in this particular section, they're going to let you leave it right like that. You should know how many answers does that give you? Gives you 2, right? Negative 5 plus the square root of 13, negative 5 minus the 13, square root of 13. So if you needed to get a decimal, if you needed it to round to, round to the nearest tenth or whatever, you grab a calculator and work them out. But since that's 2 answers, when it's 2 answers, don't I have to use set notation? So really, you should be putting this in set brackets because it's 2 separate answers. And if you're doing set notation for all of your equations that have more than one answer, then that is more than one answer. You should have 2 set brackets around it. Okay, so actually, I didn't list all of them here. Can you think of another one? Because I just thought of another one. What if you had a really simple quadratic formula? Or I'm sorry, what if you had a real simple quadratic equation? A really super duper simple one. Do you remember one called, let's add it. Do you remember one called the square root property? Completely forgot about that. You can use the square root property if you had a really, really simple quadratic formula, or quadratic equation rather. All right, so let's do an example of that. So like real simple as in, what if you had something like 3x squared equals 27? Now, yes, could I move the 27 to the left? It would be then set equal to 0. And could I factor it? Yes. But look at what these numbers are. 27 divides by 3, right? So if I divide by 3 and I divide by 3, x squared equals 9. And then how have we always solved that? Took square root of both sides? That's the square root property. Okay, so you take square root of both sides. What do you have to remember on this right-hand side? Plus or minus? Okay, so x is equal to plus or minus 3. All right, so there's no, I mean, like I said, you could move the 27 over, you could factor, but you can also, because that's so simple, you can just take square root of both sides. Now, I cannot take the square root of both sides before I divide by 3. I've got to divide by 3 so that I get down to just the x squared. Then I can take square root of both sides. All right, but if it's a nice simple one like that, I think that's faster than trying to factor. Okay. All right, another type of equations that they're going to expect you to be able to do in this section is going to be radical equations. All right, and so the same rule applies as your absolute value. All right, you want to isolate the radical. Okay, you always want to isolate that radical. Okay. So let's do one where it's already isolated. Since on the absolute value ones, we started with the more complicated ones, on this one, let's start with an easier one. Let's suppose you've got the square root of 3x plus an 18, and then it's equal to an x. Okay, so anything's got a square root in it. Now, talking about that isolation part, there is nothing being multiplied in front. There is nothing being added or subtracted outside that radical, but yet in between the equal sign there. There's nothing here and there's nothing here. So it is isolated. So what's the opposite of square root? How do you undo a square root? You square it. Okay, so I'm going to square this side. If I square the left-hand side, then I got to square the right-hand side. Okay, so the way you get rid of those is that way. So the square root and the square goes away. It's going to leave me with a 3x plus an 18 over here. And then on this side, I've got an x squared. Oh, but now I've got a quadratic equation because I just manipulated it. I changed it. I want the leading coefficient to stay positive. So leave that on the right-hand side. Move these to the right. All right, if I move that x squared to the left, it has a negative leading coefficient. We don't want to deal with that. So move these two to the right. So what? Subtract 3x, subtract 18 from both sides. That would leave me with a 0 on this left side. Put them in the order of a trinomial. So x squared minus 3x minus 18. Okay, subtract them from both sides of the equation. Now you're down to this. Does that one factor? Let's see, 6 times 3 is 18. This one factors. Okay, so we like it when it factors. So x and x, 6 and 3. Don't let me make a mistake. Let's see, negative on the 6 plus on the 3. We good? All right, so then x is negative 3, x is 6, and then I can do my little set brackets and put them in my set brackets. Now, what have I not done up to this point? Because you all skip it and everyone forgets it. No one like does it. What should you always do technically when you solve an equation? Plug it back in and check. You should always do that. And no, like as a kid, I didn't do it either. All right, it takes too much effort. However, look what's going to happen. Let's plug the 6 back in. 6 times 3 is 18. 18 plus 18 is 36. Square root of 36 is 6. Well, if x is 6 and I plug it in over here, it equals, right? So this one checks. Let's plug in a negative 3. If I plug in a negative 3 times 3 is going to be 9. 9 plus 18 is 27. Did I do that right? 9 plus 18 is 27. Square root of 27 is square root of 27 negative 3? No. Okay, so you do really seriously need to check. All right, you really do, because that one doesn't work. If you don't check, then you would have just put both of them inside your set brackets. All right. I'm going to go ahead and use, just to be consistent, I'm going to go ahead and write the answer in set notation since we've been doing them all in set notation. I didn't do that over here, though, so I probably should. Now, what type of root is this right here? It's got a word. Do we remember from Algebra 2? Starts with an E. That type of root, when you get it and you plug away in and it doesn't work, it's an extraneous root. Okay, now that I've said that, do you remember that word? Okay, well, new vocab then. It's an extraneous root because you plugged it back in and it didn't work. Okay, x equals -3 on this particular type of equation is an extraneous root. Okay. All right, you should have solved radical equations the last year. Okay. Okay, ready for the last type? Okay, these are probably going to be the least enjoyable ones. The rational equations. Okay, so the word rational we know means fraction, right? So that means you're going to see a bunch of equations that have fractions in them. All right, we don't want fractions. We want to get rid of the fractions. That should be your goal. If you've got some horrible looking equation that's got fractions in it, it's easier to get rid of the fractions and then just solve a regular equation. All right, so what they're going to look like is they're going to be things like 3 over x plus 3 equals 5 over 2x plus 6 plus 1 over x minus 2. All right, that's a rational equation. You do not want to try to solve this with all those fractions sitting in there. You want to make it more simple. All right, the way you get rid of fractions, all right, we did it the other day. When we simplified a complex rational expression, what did we do? We multiplied through by the least common denominator. When you multiply through by the least common denominator, all fractions go away. Okay, so let's write that down. Multiply through by the least common denominator. That clears fractions. That clears your fractions. Clears fractions. We did it the other day in a different type of problem. We'll do it again here, and it's going to clear our fraction scores. All right, now, easiest way to do this, x plus 3 is in factored form. 2x plus 6 can be factored because I can take out a 2. Factor it so you can see it, x plus 3. All right, and then x minus 2, you cannot. All right, now, easiest way to come up with least common denominator, take one of everything you see. All right, I got an x plus 3. I got a second x plus 3. I only need one of them. Okay, so where can I write this? I'm going to write down here, least common denominator. I've got an x plus 3. I need to keep that. All right, there is a 2. So that's going to be part of my least common denominator. This is going to be x minus 2. I want one of everything for my least common denominator. Okay. Now, we want to clear these fractions. So I'm going to take, and I write it one time. All right, a lot of teachers will take this least common denominator and write it next to each individual fraction. To me, I think that clutters the problem up. Okay. I write it once, and I'm going to start it all the way over here because I'm running out of room. So let's do 2, and then the x plus the 3, and then the x minus the 2. All right, I'm going to multiply through by that least common denominator. We know distributive property works. So if I do that like that, I'm writing it once, less on the paper. I'm not cluttering things up. All right, I did write it up high. I wrote it up high just like I did the other day in class, because this is really over 1, right? So this is in my numerator, this is in my denominator. When I do that, this x plus 3 and x plus 3 crosses out. One's in the numerator, one's in the denominator. I'm left with what? A 2 and a 3 and that x minus 2, right? That's what I want. The fraction is going to be gone. I'm going to have a 6 times the x minus 2. All right, and you can just do it with your fingers, so you don't need to literally cross things out. All right, now we're going to multiply this one. Well, what's going to cross out? The 2's in the top, 2's in the bottom, it's going to be gone. The x plus 3 is in the top over here, it's in the bottom here, so that's going to be gone. The only thing I'm going to have left is the 5 and the x minus 2. These two things and these two things cross out. The 5 and the X minus 2 is all I got left. All right, and again, multiplying through by the least common denominator, my fraction's gone, my fraction's gone. That's what I want every time. When I distribute on this last one, the x minus 2 here is in the top. The x minus 2 here is in the bottom. Those are going to go away. I've got 1 times 2 times the x plus 3, so really I just have the 2 times the x plus 3. From the first step to the second step, when you multiply through by the least common denominator, fractions go away. Now that's easy. You want the fractions gone. All right, so let's see if you can get through that. Take 2 seconds, try to work that out, and I'll put the answer up here in about in a second. See if you can actually distribute, solve, and not screw up. Anybody get an answer that wants to share? Lydia, what did you get? -8. We all get -8? All right. 6x here, a 12 here, a 5x, a minus 10, a 2x, a plus 6, and then x equals -8. All right. Where you probably would have made a mistake initially would have been that second distributive, so the -12, the -10, or the 6 could have been a screw-up problem. Or then from here to here, it would have just been, you didn't add right, didn't subtract right, some minor mistake right there. Okay, so again, this is kind of a culmination of everything you did in Algebra 1 and Algebra 2 as far as solving equations. All right, all the different types of equations. You did the easy 1-step, 2-step equations. All right, and then we introduced the identity ones and the no solution ones. Then we did some quadratics, and then you've done some radicals, and you've done some absolute value. All right, so it's just a variety of equations. So what's going to happen in this section is they're all going to be mixed up, and you're just going to have to know whichever procedure you need. The only thing that I didn't say that might be a good thing, we did the square root equals 9, and what you do, you square both sides, so then you got x equals 81, right? You square both sides. But what if it was the cube root of x equals 2? Ava? Yeah, just cube it. If it's a cube root, you cube it, so you would cube that to get rid of it, and then you'd cube that. All right, so then what? We'd have an x equals an 8. All right, and if it was a fourth root, you'd go to the 4th power. So whatever the root is, so technically what? A square root has a little imaginary 2 right there, right? So that's why we square both sides. Well, when it becomes 3, we do that. When it becomes 4, we do that. Okay. All right. So I don't know that you'll encounter that, but I just thought I'd last minute throw that in. All right. Can anybody else think of anything? Questions? Okay. Again, let me overemphasize. There's a lot of material in this P chapter because it's all review. All right. So for the test, I'm going to pick like one of everything. Like one of everything. You got 30, one of every concept. So you're going to have like 30 questions, and you got to know everything we've done in the P chapter. Okay. Any questions from anybody at home? You're all quiet out there. Doesn't sound like it. Okay. So I think we're good then. I'm going to give you the rest of the period to work.